Hello. Sorry, I'm trying to get to where I need to be. Video number 2. I had to move spots so that I could keep my Chromebook plugged in, and it looks like I'm really bright right now. Oh, well, anyway, time for line of best fit and scatter plot. So this is going to be more like what we did in class, where I'm going to fill out notes with you. We're going to talk about some more vocabulary and kind of go into a little bit more detail with it. With a line of best fit, you're looking at kind of trying to connect the dots the best way you can, where it makes sense and where it kind of covers the most ground, I guess. So you will need to use rulers when you're doing line of best fit, because it's just easier to get a straight line and to go where you want to go. Also, really important to use a pencil instead of a pen, because you might draw that line and then say, that just doesn't look right. That doesn't go through everything that I want it to go through. So when you're doing this, just try to have a pencil and a ruler, or something with a straight edge on it, so that you can draw a line the best that you can. So with this line of best fit, when you are analyzing, let me get to red. When you are analyzing, and also I want to make this bigger, a linear scatter plot. So again, something that's kind of going in a straight line. This is the line that travels through the middle of the points closest. Middle. Ooh, I love this song that just came on. So line of best fit, that's really the definition. So when you're looking at a linear scatter plot, so points that are going in a straight line, they're not going up and down and up, having a curve. So when you're looking at that linear scatter plot, a line of best fit is that line that travels kind of through the middle of the points the closest. So the way that I've always taught this is you want to have kind of an equal amount of points above and below the line, and also on the line. So you don't want to draw your line of best fit with only 1 point above and then 10 points below it, because you're not going through those points the closest. And then the steepness of a line. So obviously, this definition is talking about slope. So I've talked about this before with slope, kind of talks about how steep a line could be. And that is that rate of change, or altogether, I know you all remember this, rise over run. I know you all are listening to this on your own, and I hope you all said it out loud all at the same time when you were listening to this. Rise over run. That is that steepness of a line, or the rate of change. Next, your y-intercept. You all should know what that is as well. That is where it crosses that y-axis, that line does, or where it kind of starts the line. So this is that initial value. We'll kind of talk about that a little bit more, how that y-intercept relates to this. Sorry, it's so late. This particular lesson that we're talking about. So y-intercept is just kind of where it starts with where you put your ruler, and where the graph intersects the y-axis. There we go. And I've told you this before. If you look at this right here, whenever you're looking at a table of values and you see 0 for the x value, whatever that number is for y, that is your y-intercept. Just plain and simple. Okay. All right. So let's just talk about a little bit more about scatter plots. Those are usually used to display real world data. So in the previous or yesterday, as you all are watching this on Tuesday. So yesterday you had the graph where you had to talk to your friends or your classmates about siblings and how many chores they have. That's real world data. So you're always thinking, when am I ever going to use this math? When am I ever going to use it? Well, This is kind of, whenever you hear about people taking surveys or polling people about stuff, that's what this looks like. Using that data, they put it on a plot or a graph, and they see if there is an association between how many hours you study versus what your test grade is. Because if you study 0, that test grade is probably going to be kind of low. But if you study a lot, that's going to go higher. So that's kind of what scatter plots are used for. So they're used to display real world data, which does not usually follow a perfect pattern. It's not always going to be just straight every dot. You're going to have, maybe up here, down here, up here, down here, but it's usually going to, if it's linear, it's going to follow some sort of a pattern, but it's not going to be perfect and not pattern. All right. And then mathematicians have decided that if there is a linear trend, so kind of going up together, linear trend in a scatter plot, they can approximate the average of the points by drawing a line through the middle of the main trend. So if it's linear, we can kind of draw some sort of a line between the middle of those points. And that's going to kind of give you an average of what's going on with your data. And then outliers. They are not considered. We don't, because consider outliers. If you have an outlier, so if you got we'll look at these plots down here at the bottom. We don't kind of try to get that outlier in our line because it's an outlier. So if most people are saying, yeah, I studied 4 hours for the test and I got 100, and then you've got people that studied 0 hours and they got a 50, that's usually your trend. But you might have somebody out there might say, I studied 5 hours and I got a 50. It's probably not going to be the case. Or they said, I studied 0 and I got 100. So those are going to be outliers. That's not following the actual trend. And the next, after they identify a reasonable line for the data, they calculate the slope and the y-intercept of the line itself. So after making that line, then we can, find the rise over run and find our slope, and then look at that y-intercept, and then we can make our line. That's what we just did. Y equals mx plus b, then you make that line, or that equation of the line. They use the slope and the y-intercept to write an equation that will help predict other things about the data. So after you've made your line and you don't have any more data, you can say, okay, because I've got this equation here, I can say, keep going with your points even though you don't have any more data, if that makes sense. Okay, so let's look at some examples. So example 1, this says we've got these 3 different scatter plots showing the comparison of the age of the child and the cost of a birthday gift for that child. So this is, I think this was an example yesterday's notes. The question is, which has the most accurate line of best fit? So I'm going to look at these 3 different ones. So this is our line of best fit that somebody drew. It's the exact same data. All 3 of those graphs have the same data. And you're going to let's look at these and see which one goes through the middle the best. And again, has about the same above and below the line. It looks like most of those points are below the line. There's only 2 points above the line. Sorry, A. B, kind of the same way. It looks like most of those points are above the line. There's only 1 point, 1.5 point, below that line. So it's not really going through the middle of that data. C, looking at C, yeah, we've got, that's if I were to actually count 1, 2, 3, 4, 5, 6 kind of below that line, 1, 2, 3, 4, 5 above the line. So yeah, I'm liking C for the answer for this one. The other two options are either too high or low. So that first line is too high for all that data, and the second one is definitely too low for the data, and seem to be trying to include outliers. So it looks like they're trying to get towards that outlier, and outlier is an outlier for a reason. It just doesn't fit with that data. All right. Let's see. I want you all now to kind of work on the practice problems. So 1, 2, and 3 for each scatter plot, or each one, see which one is the most accurate. Okay, right away, I'm just going to look at number 1 with you. Hopefully you all can see which one you can already X out. That one right there, I mean, come on. That's terrible. That's a terrible line of best fits. Go in the wrong direction. So kind of look and see, by kind of counting. That's what I do. I kind of count and see which one went through the data the best with the most above and below. Oh, excuse me. All right. Do 2 and 3 on your own. Okay, so now let's look at calculating a line of best fit. So here is where we're going to start looking at the equation of a line. So for step 1, identify the slope of the line. And you don't want to use really the points on the graph. We're just going to look at the line. So remember how I said, pick 2 good points where it goes through kind of that corner the best. So, and again, it's really good to maybe start with your y-intercept if you can. So there's the y-intercept right there. And then where's another good point? Looks like this one right here. It's probably a good one too. All right, so let's look and see what this slope is. So our rise, identify the y-intercept of the line. Okay, so we've got to do our slope first. So that distance, I'm going to draw my right triangle. I'm going to go up here and then over. We're still drawing our right triangle. We have to find our points, draw our right triangle, and then do rise over run. So that distance between 2 and 6, that is 4. And then 4 over, we went over 6, so 4 over 6. So that reduces down to 2/3 if you just want to leave it as 4 over 6. So our equation would be y equals 4 over 6x, and then our y-intercept is 2 plus 2. Just going to write that right there. Voila. And there's our equation. Same thing for number 3, except the line hasn't been drawn for us. So we just have to see kind of if you've got hopefully you're following along with your notes. And if you have a ruler, go ahead and put your ruler on there and try to draw your line of best fit. See where that would go. I don't have a ruler option where I can draw a line on here. But I am going to, let's see, I see where I want my y-intercept to be. And I definitely know that it is a negative association, so that means it's going to be a negative slope. So it's definitely not that one. And I can also rule out C, because C is saying that the y-intercept is 0 because it doesn't have a y-intercept at the end. So I'm going to go ahead and knock that one out. The y-intercept probably is 9 because if you were to draw your line, it would start about right there. And then this is going to be terrible. I'm going to try to draw a line. Let's see, is that good? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, that's pretty good. Pretty good for drawing on my Chromebook screen. So I'm going to look at a point. So my y-intercept right there at 9. And then let me see another good point. I think let me do a different color. I like this point right here at 2, 8. I think I like that. So I'm going to draw my right triangle. It's negative. So, and we're going down from 9. I'm going down 1. And then I'm going over 2. So negative 1/2. So y equals negative 1/2 x. And then I said 9 was the y-intercept, so plus 9. Ooh, thank goodness that was an option. So D would be correct. Ha! I did it. Okay, so I want you all to do 4 and 5 on your own. I know you can do it. And yeah, ask your partner, for help if you want, or somebody in your group. Check your answers after you've done it, because somebody might get something different, and then you can talk about what might be different about it. All right, I am signing off for the night, and I'm going to do one more video for you, and then so yeah, you guys have a good day. Today will be Tuesday for you, so have a great day. As I try to see where I need to go. Why is this? Oh, all of your quizzes. Infinite Campus. Nope.